itself based on the integrity constraints, where we are maintaining the primary key, foreign key, and various dependencies. Function, we call it as a functional dependencies. We'll see. I will explain you what is the meaning of functional dependency. To avoid mainly the redundancy, okay, and inconsistencies. Clear? Of course, we are having one more method how to eliminate the redundancy and inconsistencies in the next module also. But here in particularly, we are seeing in terms of the various fields or columns we are using with reference to the redundancy. First of all, we'll see, we know what is the meaning of redundancy. Okay, what is the meaning of redundancy? Redundancy is nothing but having the same values at more than one place. Okay, we are simply calling it as we are having the various other definitions also, but simply say having the for the same value, okay, present in the different places, or have same element present in the different places. We call it as a redundancy, and we'll see what is the problems associated with the redundancy also. Okay, at the outset, we'll see what is the redundancy we are identifying as. It is the root cause of the various or several problems associated with the relational schemas. Okay, that means it is the major area or main area where you are getting the various problems with reference to the relational schema. Okay, that is 100% sure. Right. So to avoid this redundancy, we are using the integrity constants. In the previous module also, we identified in a little bit way how we are avoiding redundancies or inconsistencies by using the integrity constant. What happens without a value in a table, how to add in other table, or if what happens if you are deleting at one place, if you're leaving at the other places. Okay, that we are identifying the integrity constants. Okay, but the thing is that integrity constants, the way we want to define the integrity constants, okay, in particularly, okay, we can identify those integrity constants or variables to create integrity constants called as the functional dependencies can be used. Okay, in particular, functional dependencies can be used to identify the schemas, primary key, foreign keys, so that this functional dependency not only maintains the integrity constant simply restricted to the primary key or foreign key, but also it identifies the schemas wherever we can that redundancy like problems may present. It identifies the schemas with such problems. Okay, and also suggests us what is the refinement we can do, and suggests us what is the refinement we can do, how to avoid the redundancy. Okay, in order to create the integrity constants or with reference to the integrity constants. So we identified what is the meaning of redundancy. The redundancy is the root of the problem in the relational schema. What is the main problems with reference to the redundancy is we identified is it is the redundant storage, not only redundant storage, but generally it involves in insert, delete, and update anomalies. Okay, that we want to cover it in this today's class. Right. So whenever inserting anything, whenever deleting anything, whenever updating any data in the table, it creates side effects that we call it as anomalies. Okay. Whatever the problems associated with inserting, deleting, updating, we call it as the insertion, deletion, updation anomalies, right? Okay. The thing is, in the functional dependencies, using the functional dependencies, I told we can identify some refinements. That one of the refinement technique is called as decomposition. One of the refinement technique is called as the decomposition. What is the meaning of decomposition is, so let we are having a ABCD table based on the functional dependencies. Okay, or in creating the integrity constant, the functional dependencies, it may identify some problem. Okay, and asking us go for the refinement. Okay, what the refinement we can do is the table ABCD can be divided into AB and BCD, because here one column must be common. Even though we are dividing a 4-column table into 2 tables, the 2 tables can be in any other AB BCD or AC BCD, okay, or AD BCD. One column must be common. One column must be common, or in the vice versa also. Okay, so or ACD like ACD and ABD. Okay, so only thing is we are identifying at least one column is common or not. Based on this particular thing, we can divide the tables into 2 or more number of tables. Okay, but only thing is, whenever you want to apply the decomposition, you should use it judiciously. That means very carefully we need to identify, we need to apply that whether the table should be divided or not based on a requirement or the satisfied answers. We need to put some questions, and until unless we are getting some satisfied answers, we can't do those things. What are the questions should be is there a reason to decompose a relation? Is there any reason to decompose a relation? Okay, that means we need to identify why we are decomposing, why you are dividing a table into 2 or more number of tables. Are you having a satisfied answer for it? Okay, it may be based on the functional dependencies or other thing, but we must have some answer for it. Clear? Right. Not only this particular thing, if you divide that particular table into 2 or more number of tables, if you divide the table into 2 or more number of tables, is there it creates, this decomposition creates any problems? Is there this decomposition creating any problem? Okay, we are having some substantive problems whenever we are creating decomposing. We need to identify the problem. We can't invite problems for getting some small advantage, sir. No. So that whatever we are gaining should be more than whatever we are losing. Okay, so we need to identify what is the problems that may cause or arise during the decomposition. If we are having the satisfied answer, then we are going for the decomposition. Okay, that is the main essence of this particular class. Right. So first of all, once again, we identify what is the problems caused by redundancy. In the last class, I identified it. One of the problem is redundant storage. Okay, the same information stored redundantly. Okay, storing the same information redundantly at more than one place. That means at more than one place within the database. Okay, it may lead to several problems. We call it as a data inconsistencies. Right. Next problem is update anomalies. If one copy of the such repeated data is updated, an inconsistency is created until unless we modify all copies similarly, because we are having the multiple copies. Wherever you want to update, you need to update in all copies. Okay, other is called as insertion anomaly. It may not be possible to store some information unless some other information is stored as well. Okay, insertion anomaly means we want to store some information, but that inserting the data may restrict us until unless some other data is available. Okay, so for example, I want to insert information related to a student, whatever he want to enroll in a course. Until unless that student's maybe name, address, वगैरह, I can't insert the student enroll in the student enroll table because the field becomes empty. The fields becomes empty. Okay, we can't allow. So that in the insertion anomalies, in particularly when you are having the multiple copies, okay, because the information is scattered, okay, the informations are at different places also, okay, that insertion anomalies may lead to us big problems. Similarly, deletion anomalies. Sometimes what happens is you want to delete something, but because you want to delete something, it may leads to losing other information also. Okay, because of the redundancy. Generally, what is the problem is that the redundancy means when the all data is placed at one place, it may be at one table, maybe stored at different places. That is a different thing. Okay, not only that particular redundancy means the redundancy also happens. The redundancy also happens when the all data is stored at one place. Okay, at one place means at one table. Be careful. This concept is different. That is different. In this even single table also, we may repeatedly storing some information. Whether it is a different places or not. Even in the single table also, if you are storing information repeatedly, that is also called as redundancy. Okay, don't feel redundancy means having the same data at different places, but also at the single place also. In the single place also, we are storing same information repeatedly, whether it is required or not. Okay, that is also called as a redundancy. If you are storing, if you are repeating the information at one place only, okay, that insertion anomaly occurs until unless we know something we can't insert up. At the same time, uh, whenever you want to delete something, automatically it may delete other information also. Okay, okay, we'll see this in detail in the coming classes. Be careful. Okay, entire unit is on this particular thing. Next, say for example, in order to identify this particular thing, consider a relation that may be translating variant of hourly employed, okay, or employees entity set. What is hourly employees? Okay, that what it is basically is it identifies employees hourly pay, hourly wages. This table contains maybe is employees SSN number, the employee's name, LOT, loss of place, okay, and rating, hourly wages, hourly work. Okay, here is the key is SSN number. Suppose that hourly wages is determined by the rating attribute. Hourly wages attribute is okay. We are concentrating now on column level. Be careful. Whether we are identifying whether each the column is depending on each other or not, are related or not. One more thing is we are getting the redundancy because if you are keeping the data, irrelevant data together, okay, in one table, okay. So now if you feel that hourly wages attribute depending on the rating attribute, hourly is based on the value. Okay, that means for any given rating value, there is only one permissible hourly, whether it is the employee 1 or 2 or 3 or anybody. Be careful that we need to maintain. Okay, so this integrity, this is also called as the integrity constant. One of the example of the functional dependency. That
Also,
functional dependency.
one
What
comes
is
from
the meaning of this functional? What is what is the meaning of this functional dependency? What is the meaning of this functional dependency? We are going to identify in the next class. It leads to possible redundancy in the relational hourly employees worked. Okay, so that means if you know the rating, we also know the what is this wage, hourly wage. Okay, because it is depending on this rating only. Why both if you are repeating this rating and hourly wages also along with all employees, definitely either rating is duplicate or wages is duplicated. Okay, we are storing the same information repeatedly in the same table. It is nothing but redundancy. It is nothing but redundancy. For any rating, hourly wages is same, but we are saving both information in all possible combinations, in the table. Okay, Mm. That we are calling it as a redundancy, right? So what we need to do if you are getting this that redundancy. Okay, what we identified in the previously, the hourly wages are rating here together, but we are storing those both attributes repeatedly. It is nothing but duplication. Okay, what we need to do, we need to use go for the decomposition, dividing the particular table into 2 or more number of tables. Okay, so the thing is redundancy arises when the relation schema forces an association between attributes that are not in natural. Okay, redundancy arises when a relation schema association between attributes that are not in natural. Here the thing is, here when we are identifying this particular thing, the hourly wages pay, but hourly wages is not need not to store every time for a particular SSN name or particular SSN. It is little bit unnatural. It is little bit unnatural. No need. Okay. Okay. For whenever we are seeing a particular employee, we can identify how many hours he worked for a particular day. But need not say every day what is hourly wages, because when you know the rating, we also know the hourly wages, because hourly wages is depending on rating. Okay, so here hourly wages with reference to the particular name is unnatural. Okay, that association is unnatural, right? So the functional dependencies can be used to identify such situations, and it suggests the refinement. Okay. Okay, to the schema. So the essential idea what we hear is many problems may arise during the redundancy that we will address later once again, can be in particularly that redundancy problems can be addressed by replacing a relation with collection of small relations. Each of the smaller relation contains a subset of the attributes of the original relation that I shown from as ABCD to AB and ACD. Okay, or AB, BCD. Okay, we refer this particular process as the decomposition of the larger relation into the smaller relation. Okay, so what we need to do that particular table, because we want to say whenever, because we know about storing, we also know the wages. The hourly wages need not be repeated uh, for the each and every SSN number and name. We divided into the different table. We divided into the different table. Okay, so in the table number 1, we are keeping SSN name, LOT, rating, hourly worked only. Hourly wages we are not using, because hourly wages need not be repeated, and hourly wages we are storing as separate table along with the rating. So what is the common field in this particular two thing? Rating. Okay, rating. So here by dividing this particular table, we are reducing some redundancy. What redundancy we are reducing? Hourly wages. At a rating 8 unte, but hourly wages ఎప్పుడు కూడా అట్టనే, irrespective of the employee, irrespective of the employee. Okay, so we need to repeat this information in the same table, okay. So one more point here, what we identified, redundancy means not saving the same information repeatedly at the different places, but also in the same table. If unnecessary information is repeating, it is also called as a redundancy. Here our concentration is how to avoid the redundant data inside a table also. Okay, that is much more important thing. Okay, by using the centralized database, anyway we are avoiding multiple copies. But what happens if this information in the same database, or in the same table, that will be avoided using the decomposition. Okay, right. So here simply we are using the rating and hourly worked. The rating is here. If you are using the along with the rating, if you are using hourly wages also, it appears twice. What unnecessary? Similarly, whenever you, even this 80 three times, that hourly wages also repeated three times, unnecessary. One time is sufficient. Similarly, 5 is also appeared twice. Okay, unnecessary appeared the hourly wages also, that we avoided. Okay, right. So, but the thing is, whenever we are doing this decomposition, we are getting the some problems also. Okay, that we identified earlier in the one. We can't simply divide this particular table into two or more number of tables to remove the redundancy, but the decomposition also creates some problems. What the problems may comes is, whenever you want to do this particular question, first of all, we need to ask two questions. If you satisfied only, then only you can, if you satisfied only, you can go for the decomposition. Otherwise, don't go for the decomposition. Okay, so what are those two questions are? Do we need to decompose a relation? What is the reason we are decomposing? What is the reason we are decomposition? Okay, we need to identify this particular question. We'll see what is the, in what way we can do that particular answer. Similarly, what problems does a given decomposition may cause? We decompose చేయాలా లేదా, ఒకవేళ చేస్తే ఏం ప్రాబ్లమ్స్ వస్తాయి? ఈ రెండు క్వశ్చన్స్ మనం రిపీటెడ్ గా వేసుకోవాల్సి వస్తుంది. సో ఓకే, so first of all, within the first question, several normal forms we are having. Okay, in the theory, we are going through that particular normal forms: first normal form, second normal form, third normal form, BCNF normal form, fourth normal form, fifth normal form. Okay, projectile normal form, multi-value normal form. We are having the various the normal forms. That normal forms give us the solution for the question number. Okay, do we need decomposition? We are having the various normal forms. These normal forms give us a solution. Okay. If there is a forms, if we revise one of these normal forms, we know that certain kind of problems may not arise. Okay, ante ఈ మన టేబుల్ ఆ నార్మల్ ఫార్మ్స్ లో ఏదైనా ఒక నార్మల్ ఫార్మ్ కనుక సాటిస్ఫై చేస్తూ ఉంటే ఆ పర్టికులర్ టేబుల్ కొన్ని ప్రాబ్లమ్స్ క్రియేట్ చేయదు. కొన్ని ఆర్ ప్రాబ్లమ్స్ మే నాట్ అరైజ్. Okay, so first of all, we are identifying whether this particular table is satisfying any of the normal form or not. Considering the normal form of a given relational schema can help us or to decide whether or not decomposition it further or not. Okay, based on the normal forms, so we are identifying whether we need to decompose a relation or not. Okay, the first question is, do we need to decompose? Okay, how we are getting the answer? We are having the various normal forms. Using the normal forms, okay, it tells us whether we need to decompose or not. If we decide that a relation schema must be decomposed further, we must choose a particular decomposition. Okay, a particular collection of smaller relation to replace a given relation. ఏ విధంగా decompose చేయాలి? ఓకే, ఏ attributes ఐడెంటిఫై చేసుకోవాలి, అది పర్ఫెక్ట్ గా ఐడెంటిఫై చేసుకోవాల్సి వస్తుంది. రైట్. నెక్స్ట్, with reference to the second question, okay, what problems may arise? What problems may arise if you decompose a relation to two or more number of relations? Okay, we are having the two particular properties of a decomposition are very much interested. Okay, two properties of a particular decomposition or a particular table, okay, or decomposition are very important. What are those two properties are? Lossless join property. Property number one is lossless join property. What this lossless join property is telling us? It enables us to recover any instance of the decomposed relation from the corresponding instance of the smaller relations. Lossless join property and say, for example, here we are having the various other points also we need to discuss. Okay, whenever we are decomposing based on the queries we are using, be careful that point may be properly explained today. Okay, but the thing is, sometimes we don't want the decomposition also. That question also arises based on the queries we are using. ఓకే, అంటే డివైడ్ చేస్తే మళ్ళీ న్యాచురల్ జాయిన్ చేయాల్సి వస్తుంది, లేకపోతే కార్టేషియన్ ప్రోడక్ట్ క్రియేట్ చేయాల్సి వస్తుంది. దట్ ఈస్ we identified as part of the query. Okay, in the from class, if you are using the more than one relation instead of the single relation, you need to create a Cartesian product. The Cartesian product is creating more number of rows. If we are having the more number of rows, automatically it slows down. Okay, if the speed is important, okay, we don't want decomposing a table into two or more number of tables. Instead, we want to use only single table. If the speed is important, we want to use only single table where all data is available, even though it contains some redundancy. Okay, right, that is the first thing. So whenever you feel you realized speed is more important, instead of maintaining the two tables, you want to only single table, then what do you do? Whatever the previously you divided the table into two tables, you need to join once again. You need to create a single table once again. Okay, but whenever you are going back from the two tables to a single table, it has to create your original single table without losing any data. I will demonstrate this particular thing in the coming classes. Okay, right, so that we call it as a lossless join property. Sometimes after dividing into two tables, if you join those two tables or even creating the Cartesian product, you may not get the original data. It should not. Okay, so the decomposition must satisfy lossless join property. That is the number one. Number two, dependency preservation. Okay, what is the meaning of dependency preservation? Means, okay, as I told you previously, we are having some functional dependencies. We are identifying whether the data is depending on each other or not, or proper columns or related columns in the table or not. We are identifying in terms of functional dependencies. Here we are identifying after decomposition also into a bigger table into smaller tables. Whatever the corresponding dependencies, say C is depending on A. After division also C must be along with A only. You can't divide AB in one table, BCD in the other table, but that because there is a relationship between A and C. A and C must be in one table. If you divided AB in one table, BCD is another table, it is violating the dependency preservation. Okay, so this dependency preservation, are you able to understand this what I am telling you? In the ABCD table, C is depending on A. After division, C must be along with A only because both are interrelated. You can't make AB in one table, BCD is untable. If you do that, C becomes independent, A becomes independent. There is no dependency preservation. Okay, right. So the dependency preservation property enables us to enforce any constraints that original relation, okay, are maintaining, or the original relation by simply enforcing some constraints on each of the smaller relations also. Okay, ఒరిజినల్ టేబుల్లో ఎటువంటి కాన్స్టెంట్స్ ఎటువంటి రిలేషన్షిప్స్ అయితే ఉన్నాయో అవన్నీ కూడా చిన్న టేబుల్స్లో కూడా మెయింటైన్ అయి తీరాలి. Okay, so we need to identify that particular aspect also whenever to decide how to create a smaller tables. Okay, right. So that is, we need not perform joins of the smaller relations. Okay, perform joins of the smaller relation where you are doing the smaller relations, joining of the smaller relations as part of the from class. Okay, after doing the Cartesian products or any other thing, the weight was removing and be careful. It is eliminated only. Okay, so we need not put the smaller relations to check whether a constraint on the original relation is violated or not. Okay, so for identifying the integrity constraint violations, we can't use one table with other table and join using the join conditions and join is taking place or not. The integrity constraint violation is simply the small there itself. Okay, that we need to what is the serious drawback of this uh, decomposition is that a serious drawback of the decomposition is that queries over original relation may require us to join the decomposed relations. Okay, if you want to get original table information, if you want to get the original table information, we need okay, queries over the original relation also. Okay, so that we can get the so that we can get the original data. That through queries only, be careful, through queries only we are creating, through queries only we are joining the tables. Through joining the tables only we are getting the original table. Okay, whenever you want to check the original data, you need original queries. Once again, it is one more burden on us. Okay, that is the reason I told you, whether you want speed is important, speed is important or redundancy is important. Okay, we need a common approach. We need a common approach. Okay, to identify the performance of the queries. Okay, at the cost of the decomposition. At the cost of the decomposition, if the speed is important, we need not go for the decomposition, or at least more number of tables. It can be 1 or 2 tables, no problem, but we can't decompose into more number of tables if the performance is important. Okay, because when you identify, you are having the more number of queries, as the queries are more common by joining the tables. By joining the tables, if the more number of queries are based on multiple tables, if the more number of queries are on multiple tables, we don't go for the decomposition. Okay, so it becomes a performance penalty for us. Okay, right. So basically, if the performance is important, we are not decomposing. If the redundancy is important, we are decomposing. Okay, if performance is important, we are not decomposing. If the redundancy is important, we are decomposing. Okay, so in this case, we may choose to live with some of the problems of the redundancy and not decompose the relation. Okay, so if performance is required, okay, let it be, some redundancy may be acceptable. Okay, so that it is very important to aware that potential problems caused by the residual redundancy. Residual redundancy means the redundancy within the particular table. Redundancy within the particular table. That is the meaning of residual redundancy. Okay, but only thing is we need to aware. We need to aware what happens if the redundancy available in the same table, that we call it as a residual redundancy. We call it as a residual redundancy in the design, and to take steps to avoid them. Okay, so in what way we can avoid this, particularly by adding some checks to application code, okay, in the programs. Okay, right. If you are having any doubts, you can ask me. Okay, otherwise you give your attendance. It is only less than 2 minutes time. That other